we're going to see several examples of how to apply Kirchhoff loop rule. This rule does not always hold. It depends if we are talking about electrostatics, in which there is no magnetic field that could induce a voltage or electric current as subsequent. Here we are going to talk about only circuits with no magnetic field, so with no conductors. So in these examples, Kirchhoff's loop rule can hold, and so we will use it. Actually, we will see that Kirchhoff's loop rule is just an instance of Faraday's law. Well, anyway, this law states that the closed loop integral of the electric field dl, that is of the voltage, is always 0. So here we have a circuit. If we begin from here and we take all the turn around and we go back exactly to the same point, we have 0, and we can begin in any point that we want, wherever it be. And also for the current, the total current would be equal to 0. So the current cannot accumulate. For example, whenever we have a node, that is, for example, here we have a node. We have different current coming through this point, but all the current that is coming here is the same current that is going, because the current cannot accumulate. Alright, so we will begin with this. There are many ways of solving this problem. We will do it first in one of the most intuitive forms. That is, we need to choose a convention of the signs for the voltage. That is, if we go from plus to minus, or if we go from negative to positive. So the convention that is usually used is that if we go from positive to negative, so if the voltage goes from positive to negative, we will put it as a drop in the voltage. So there will be a drop in the voltage, because as we normally think that the current is going from the positive end of the battery to the negative end, if the electrons will go from the positive to the negative terminal, we are decreasing the voltage across them. So there will be a decrease in the voltage. And so we will say that if the voltage goes from negative to positive, so in this direction, there will be an increase in the voltage. But you could have chosen in the other way around.